Well, again, everyone, welcome to another, and for this session anyway, a final lesson of Sun Devil Learning Labs from Arizona State University. At least this series that's on fractions, I'll be wrapping things up today with our second part of our review. My name is Michael Barker. I'm your instructor. And we do have an objective today, though. We want to solve and create fraction word problems involving subtraction and multiplication. I know a lot of you struggle with word problems. It's probably the biggest problem a lot of people have in math, but it helps if we identify what we're working with. We've given you some tools along the way. And if we find out what we're being asked and what we know, a lot of times those solutions are pretty straightforward. Now, before we start, I wanted just to remind you of a few things, my same basic rules. First, I want you to make sure that you're in a comfortable setting with no distractions. And by that, I mean, you don't want your little brother or sister running around. You don't want the dog barking in the background or the TV or music on real loud. It's just going to make it harder for you to complete the lesson, and you won't be able to devote full attention to it. If you need to, you may have to ask your parent or guardian, whoever's in charge, to maybe help you with that. Keep little brother or sister out of the way, or the dog out of the room. Second, I want you to gather any supplies you might need today. As usual, I always suggest a few pencils, a notebook. Again, I hope you've been keeping a notebook for most of this series. If you haven't been, at least several sheets of paper. Scissors probably won't need today, but it doesn't hurt to have them. And a ruler is always helpful for drawing whatever. It could be a place value chart, it could be an area model, it could be a tape diagram. A ruler just kind of helps you space things. Even if you're not measuring precisely, you can at least draw straight lines. Third and finally, be sure and use the restroom before we start. And remember, you can always pause the video if you do need to take a break. Another thing about pausing the video is if you need to come back and work on something again or just revisit it, all you have to do is pause, rewind, and take your time and make sure you grasp what we're working on. Mathematics is a subject that it builds, so if you struggle with a topic, I recommend you go back and revisit it. So now let's move to, it's going to be our first, just a little sprint review sheet. This shouldn't take you more than a couple of minutes, but it's just something to keep you fresh and kind of get your mind working. And I'd like to ask you to circle the smaller fraction. It's a simple worksheet. The directions are here. And when you come back, it shouldn't take you more than 2-3 minutes. And when you come back, we'll go over the solutions. Okay, we're back. And here's the solutions. And I hope you can see that most of them, as I said, pretty straightforward. You've been doing these a lot. Sometimes I was able to do them in my head, but I want you to pay attention to like the last three. If you'll notice, it wanted to know if 7/8 was smaller than 64/72. So what did we have to do? We had to convert like units. 7/8 is equivalent to 63/72. So it's not much smaller, but it is by a hair. Same thing here, 47/54 is smaller than 8/9 because when we do the math, 8/9 is equivalent to 48/54. Again, 1/54 smaller, but that's how we determine the difference. And the last one, 65/72 is smaller than 66/72. Again, by 1/72. If you don't do the math, if you can't make like units, you're going to struggle with these concepts. So this is something that I always try to add in and give you a little bit of practice and just do these comparison worksheets. So for now, I think we're ready to move on to I'm going to model a problem for you, and then we're going to work on some more in our review. So our practice problem 1 is that in a classroom, 1/6 of the students are wearing blue shirts. 2/3 are wearing white shirts. There are 36 students in the class, and how many students are wearing a shirt other than blue or white? Tell you what, take just a minute or two and don't try to solve really, but either highlight or circle what you think is important And then when we move to the next part, we'll solve it together. Okay, here's our problem. There's a lot of solution stuff here, but I think I want you to focus on first. Hopefully, I've been using a red highlighter in most of the series, and we often underline this as well. In cubes, we want to underline what the question is. How many students are wearing a shirt other than blue or white? So that's our question, how many? And then we use yellow. I highlighted in yellow, just in the slides it's easier. You could have circled, what do we know? And we know that 1/6 of the students are wearing a blue shirt. 2/3 are wearing white shirts. And we also know that there's a total of 36 students. Let's break that down. I'm going to start with 36 students, and I'm going to make a tape diagram. So the first thing I did was I drew our tape diagram, and I knew my whole was 36 students. That was really easy. So how do we divide our tape diagram into, how do we know how many sections we want? Well, one of our fractions was 1/6, and the other was 2/3. So we know our smallest unit's going to be 6. And we also know that 1/6 and 2/3, the 2/3 can be easily, the equivalent fraction would be converted to 4/6. So let's take a look again. 1/6 of the students are wearing blue shirts. We broke our model into 6 parts. So one of those 6 is blue. And then we also said that 2/3 or 4/6 are wearing white. So there's 1, 2, 3, 4/6, equivalent to 2/3. I know a lot of this is probably getting pretty simple for you guys, but we're just going to work our way through it. And then finally, our last question, how many students are wearing a shirt other than blue or white? That's what we don't know. So that's the problem we want to solve. Well, we can look at it over here, and our question is really 36 multiplied by 1/6 plus 2/3 is equivalent to 36 multiplied by 5/6. And if we want to work it out, we do our math, 36 multiplied by 1 multiplied by 5 over 1. We can simplify, and it gives us 30 over 1, or 30 students are wearing white or blue. So all we have to do now is subtract 36. We'll subtract 30 from 36, and that'll tell us that 6 students are not wearing white or blue. But there was another way we could look at it too, and it's kind of our shortcut method. We know that 1/6 of the students are essentially unaccounted for. So all we have to do is really multiply 1/6 of 36. Simplify again, 6 becomes 1, 36 becomes 6, and we wind up with a total of 6. 1/6 of 36 is 6. And then when we write our answer to our word problem, we're going to write it in a sentence, and we can write 6 students are wearing a shirt that is not blue or white. And we've done enough of these so that I think the solution process should be pretty simple for you. So I think it's time for you. I'm going to give you this one, and then take a shot at this one. A baseball team played 32 games and lost 8. Katie was the catcher in 5/8 of the winning games and 1/4 of the losing games. So what fraction of the games did the team win? That's your first part, A. And then second, B, and how many games did Katie play catcher? So you've got a couple of things to ask here. Take 4 or 5 minutes, work on the problems, and when you come back, I'll model my solutions for you. Okay, welcome back. I hope the first thing you did was highlight the questions. We had 2 questions. What fraction of the games did the team win? And B, how many games did Katie play catcher? What did we know? Well, we know the team played 32 games and that they lost 8. All helpful information. We know that 5/8 of the winning games and 1/4 of the losing games was when Katie played catcher. Also helpful information. So let's look at how we solved and attacked this problem. I'm going to give you two methods. You could have done it either way. You may have even had a method of your own, but these are probably the two most likely if you've been following the program. We use a tape diagram in method 1. And what do we know? We know that there's 32 total games played and they lost 8. So if we break our tape diagram into 4 parts, we wind up with 32, and we subtract 8, we wind up with 24. 24 parts of 32 is equivalent to 3/4, which is represented in our tape diagram. 1, 2, 3, 4, and they lost 1/4, which means they won 3/4 of their games. So now in method 2, we could have said they played 32 games, they lost 8. We could have just said 8 30-seconds is the same as 1/4. 4/4 minus 1/4 is 3/4. The team won 3/4 of its games. And that's all that they were asking us in the A question. What fraction of the games did the team win? Hopefully the solution you came up with was 3/4. Now let's look at how many games did Katie play catcher. Okay, well, she played in 5/8 of 24 games that they won, right? We figured out 24 up here in the first part. So 5/8 of 24, 5/8 multiplied by 24, we can simplify, we wind up with 15 over 1, 15 games. And now we want to know how many did she play in when they lost? Well, she played in 1/4 of 8 of the losing games. So 1/4 multiplied by 8 over 1. Simplify again, we get 2. So she played in 2 of the losing games, and that tells us that Katie played in 17 games total. Now, if we go back to our method 2, we can find the same solution. We can go back to our tape diagram. We already know they won 24 games. So we know she played in 5/8 of the winning games. We break our tape diagram into eighths, 1, 2, 3, 4, 5. And we know that 5/8 of 24, simplify, 8, 24, this should be old hat now. 15 games is how many she played in there. We can also draw a tape diagram for how many games she played in when they lost. There was a total of 8 games they lost, and she played 1/4 of them. We break our tape diagram into 4 parts, and 1/4 of 8 is the same as 2 games. So 15 games she played in when they won, and she played in 2 games when they lost, for a total of 17 games. So again, Katie played 17 games, and that would be the answer for our first problem. Let's move to question 2. Mrs. Elliott's garden, 1/8 of the flowers are red, 1/4 of them are purple, and 1/5 of the remaining flowers are pink. If there are 128 flowers in all, how many flowers are pink? Again, take a second or two. It'll probably take you 3 or 4 minutes to solve the whole problem, but take a second or two first and highlight or circle. Just make sure you mark and notate what you know, and then I'll come back and give you my solutions. Okay, problem 2. A couple of things we knew. The question was, how many flowers are pink? And what did we know? Well, we knew 1/8 of the flowers are red. We knew 1/4 of them are purple. We knew that 1/5 of the remaining flowers, we got to remember that part, of the remaining flowers are pink. And we knew there was a total of 128 flowers. So let's look at our first method. We knew out of the red, 1/8 of 128 total flowers were red. We do the math, 1/8 of 128. We can simplify our fractions. 1 multiplied by 16 is 16. So we knew 16 red flowers. How many purple flowers were there? Well, 1/4 of them are purple. So 1/4 of 128, we do the math, 1/4 of 128. Again, we simplify our fractions, and it tells us 32 flowers are purple. So now we know there's 128 flowers total. We want to subtract the red ones and the purple ones, and that gives us a total of 80. But are we done? No, because our last question was only 1/5 of the remaining flowers are pink. So what do we do now? Now we have to look at 1/5 of 80. That's what's going to tell us 80 was the remaining flowers, and 1/5 of 80 is going to tell us how many were actually pink. Again, set up our fractions. 1/5 multiplied by 80 over 1. We simplify. 5 will go into 80 16 times. So we know 16 is our solution. 16 of the flowers are pink. We could have also just took the information, 1/8 plus 1/4 is the same as 1/8 and 2/8 is 3/8. So now we knew that 3/8 of 128 flowers were either red or purple. Do the math, and we knew that 48 flowers were red or purple. Well, 128, we'll subtract the 48 red and purple flowers, and here we are, we're back at our 80 total flowers left. 1/5 of 80, again, it's the same math as we did here. We simplify, 16 flowers are left. Hopefully you can see this, and hopefully one of these solutions is mirrored in something you did. Now, if you're still using tape diagrams, I'd like for you to think that this is a little simpler, but in this case, this model was pretty simple. 128 total flowers, and what were we working with? We had 1/8 and 4ths, so we knew we could break everything into parts of 8. 1, 2, 3, 4, 5, 6, 7, 8 total unit parts. So, and how many were red? Well, 1/8. How many were purple? 2/8, 1 and 2. So now we knew the remaining units were 1, 2, 3, 4, 5. What a coincidence. We knew that the pink flowers, 1/5 of the remaining flowers are pink. So now all we have to do is multiply our 1/8, which is our unit here, out of 128 total flowers. 1/8 multiplied by 128. Again, I know you're going to tell me now, 16 flowers. 16 of the flowers are pink. So really, there's 3 different methods that I've demonstrated here. You might even have another shortcut that you know for yourself, and that's great. What you can do is solve whatever way you're comfortable with, and sometimes use an alternative method to double check your work. Especially if you have enough time to double check, I always prefer that you double check your work, because you may notice a simple mistake you made in one of the other methods. Let's move to problem 3. Lillian and Darlene plan to get their homework finished within 1 hour. Darlene completes her math homework in 3/5 of an hour. Lillian completes her math homework with 5/6 of an hour remaining. Question is, who completes her homework faster and by how many minutes? So take a few minutes, highlight what we know, don't know, or what we think we need to use to solve the question, and I'll be back to go over the solution with you in a minute. Okay, we're back. What's our question? Well, who completes her homework faster and by how many minutes? That's what they're asking us. That question mark a lot of times is our hint. And what do we know? Well, they plan to get their homework finished within 1 hour. That's going to be a key component. And Darlene completes her math homework in 3/5 of an hour. Lillian completed her math homework she still had 5/6 of an hour remaining. So now I hope you caught on here that one person tells us how much time they spent, another tells us how much time they had left. That is going to be a factor in how we solve our problem. There's another thing at work here too. Because we're using fractions of an hour, we probably want to convert to minutes. And hopefully in a younger grade, you've learned that 1 hour is equivalent to 60 minutes. I'll write that there for us and we can keep it going. So let's look at our first solution. What do we know? We know Darlene completed her homework in 3/5 of 1 hour. So 3/5 of 60 minutes is 36 minutes. That's all pretty straightforward. 3/5 multiplied by 60, we simplify the fraction, 36 minutes. Now, Lillian, 5/6 of an hour remaining is what happened. So how long did it take to do her homework? 1/6 of an hour. So now we only want to multiply 1/6 by 60 minutes, and we simplify, and it only took her 10 minutes to do her homework. So Lillian did her homework in 10 minutes. Darlene did hers in 36 minutes. So the question is, who completes her homework faster and by how many minutes? Well, 36 minutes, and we'll subtract the 10 minutes it took Lillian, 26 minutes. Lillian finished 26 minutes faster than Darlene. Now, if you wanted to use a tape diagram, we can look at method 2. First, we know Darlene worked in 3/5 of an hour. So we're going to break our tape diagram into 5 parts, 1/5, 2/5, 3/5, what she worked, 4/5, and 5/5. We knew our whole was 60 minutes. So we know that 60/5 is the same as 12 for each 1/5 unit. So 12 minutes, so 3 units multiplied by 12 is going to give us a total of 36 minutes. It took her 36 minutes to complete her homework. So now we already figured out earlier that Lillian, because the question was kind of trying to trick us, 6/6 will take away the 5/6 that she had left. She only spent 1/6 of an hour on her homework. Her tape diagram needs to be broken into 6 parts, right? 1, 2, 3, 4, 5, 6, but our whole is still the same. So now we want to know 66 is equivalent to 10. We just took our 60 divided by our 6 units. Each unit has a value of 10, and we're only using 1. So 1 multiplied by 10 would give us 10 minutes. We now have the information we need to answer our question. 36 minutes for Darlene. We'll subtract the 10 minutes it took Lillian. It gives us 26 minutes left. So Lillian finished 26 minutes faster than Darlene. Let's move to another problem. This is our 4th problem. And in this one, I'm going to turn it around a little bit. I'm going to ask you to create a story problem about a baker and some flour, whose solution is given by the expression 1/4 multiplied by 3 plus 5. So now, this is where I'm going to ask you to be a little creative. There's really no wrong answer as long as your math is correct. You could have used almost any sort of story. And I'm going to give you 2 models. And of course, you could have had more, but I want you to pay attention to the numbers as well, because there was 2 different ways I solved it. And I hope you see the difference. And you could have even came up with a 3rd or a 4th way to ask your question. Let's look at my first story. So I said, the party chef mixes 1/4 of a cup of sugar, there's our 1/4, into each cup of flour. He uses 3 cups of wheat flour, there's our 3, and 5 cups of rice flour, there's our 5. How many cups of sugar does he use in all? That's our question. So we had 1/4 of sugar, and he's going to multiply that by 3 plus 5. So 1/4 multiplied by 8 now, right? 3 plus 5 is 8. So we have 1/4 multiplied by 8 are 8 cups of flour. We simplify, and you get 2. 1 multiplied by 2 is our numerator. 1 multiplied by 1 is the denominator. 2 is the total. He used 2 cups of sugar. It could have been another story. We could have looked at it this way. He could have combined 3 cups of sugar with 5 cups of flour together in a bowl. So then we're going to say he used 1/4 of the mixture to make cookies. How many cups of the mixture did he use? Slightly different question, but it still came up with 1/4 of 3 plus 5. So what do we get? We get 1/4 multiplied by 8/1, and it gives us a total of 2 again. This time our answer, though, is he used 2 cups of the entire mixture. Just 2 different ways to solve the same problem, and hopefully this problem helps you work a little bit, and I don't want to say backwards thinking, but thinking in the reverse way to try and solve some of these problems when you look at it. Again, we always have our question of what is the final question? You need to have that. How much, what are they asking? And then what do we know? We highlighted all that stuff in both of our stories, and that's what would let us come up with our expression that we use. This way we just had the expression first. Okay, finally, let's move on to one of our last question. Of the students in Mr. B's 5th grade class, 1/3 were absent on Monday. And of the students in Mrs. Jacobs' class, 2/5 were absent on Monday. If there were 4 students absent in each class on Monday, how many students are in each class? Again, take a few minutes, highlight what you know, underline what you know, circle it, and then we'll come back and we'll work over the solution. And here's what I did. So the first thing the question is we need to find a whole, right? And all I wanted to know was how many students are in each class. So let's look at Mr. Smith first. Mr. B, I thought, Mr. B, Mr. Smith, I wrote the wrong thing, but Mr. Smith is Mr. B, and 1/3 were absent. So we know if we draw a tape diagram, we can break it into thirds, 1, 2, 3. We don't know the whole, but we do know that 4 students were absent in each class. So if we count the absence, we should be able to figure out the whole. So 1/3 of the students is equivalent to 4. So that tells us that 4 multiplied by 3 would give us 12, right? We have 4, 8, 12. If we just wanted to add 4 plus 4 plus 4, or 4 times 3 is equivalent to 12. So there are 12 students in Mr. Smith's class. Mrs. Jacob, on the other hand, now she had 2/5 absent. So we want to break our tape diagram into fifths. 1, 2, 3, 4, 5. Let's account for the 2 absent students. And what do we know there? That 2/5 is still equivalent to 4. So if 2/5 is equivalent to 4, we should be able to figure out 1/5 is equivalent to 2. So then if we know that 5 multiplied by 2 is 10, that tells us that there are 10 students in Mrs. Jacobs' class. So what I'd like you to see is, though, even though 4 kids were absent in each class, because our whole is going to be different, that changes our fraction. 1/3 was equivalent to 4 in one classroom, and 2/5 was equivalent to 4 in another classroom. So we really have to emphasize making sure that we're working with the proper number of units when we set up a tape diagram and we try to find our whole. Because obviously it'll make a difference to the teachers when they want to count how many students are in their class. You know, and that about wraps it up for this lesson. I want to thank you for taking your time and working on these. If you look in the learning guide, or if you just consult some of the other previous Sun Devil Learning Lab lessons, you can always review and go over any more information that you'd like that we covered in this semester. But I want to say thank you again for your time and patience and paying attention to these lessons, and continue forward, and we'll be here with more lessons next semester. Thank you, and enjoy the rest of the summer.